Your City is on location tonight. We're at the University of Alberta to tell you about a nanotechnology conference. International delegates are here from all over the world. Why Edmonton, you ask? Because we are the Centre for Nanotechnology in Canada. Good evening, everyone, and welcome to Your City. We are coming to you from a nanotechnology lab here at the University of Alberta. There's a huge conference going on in our city right now. It's just getting started today about nanotechnology. This is a keynote speaker here. It's Dr. Paul Burrows, refers to himself as a science and technology consultant. You're giving a talk on Nano 101, basically. So perhaps you can give us a little bit of insight into nanotechnology.
Well, nanotechnology, you've really got to come at the word from two different angles because it's very easy to define, but a little harder to understand what the significance is. Nano, the word, is just representing a fraction. So just like a millimeter is a thousandth of a meter, a micrometer is a millionth of a meter, a nanometer is a billionth of a meter. And when you get that small, exactly, when you get that small, you're really only dealing with a few handfuls of atoms. So nanotechnology is simply the technology that allows us to make and manipulate matter on that scale. But that tells you nothing about the true significance of it. To understand the significance, you've got to know a little about electrons. Now, we're all used to thinking of electricity as electrons flowing in a conductor, just like water flows down a river. But it turns out that even in a non-conductor, the properties of the electrons really govern all of the properties of the material, like color, hardness, strength, and even chemical properties, which is where the real potential lies. Now, when you make a piece of matter on the nanoscale, about a nanometer in size, it's so small that those electrons start to feel the walls of the material. And that moves their energy and their position. And that means you can tune the properties of the material by structuring it at the nanoscale. And the most important aspect of that is we can actually design and make materials with new chemical properties using nanotechnology.
Okay, now, what sort of industries is this going to be used in?
It's going to be very cross-cutting. I mean, that fundamental ability to manipulate materials gives you really flexibility that we've never had before. I sometimes call it the first major revolution in industry since the Stone Age. Because in the Stone Age we started finding lumps of rock and chipping away at them to make useful tools, but we've never been able to create the fundamental materials to enable new applications. And a very significant application of nanotechnology will be in energy, where, for example, tuning a material to store energy in a battery fundamentally requires us to manipulate that material on a nanoscale, and that allows us to create new and sustainable energy solutions for the future.
Is there anything to be concerned about this? Because so often with new technology, it's ahead of government regulations. Is there a fear involved with this technology at all?
Well, there is. Look, there's no such thing as zero risk. Okay, of course nanotechnology carries risk, but the beauty of it is it's actually less risk than what we do now.